In this problem, we are given a pretty complex circuit diagram. We are asked to find the equivalent resistance seen by the source. We are asked to find the current I0 through the 4 ohm resistor, and then we are asked to find the voltage V0, which is actually separate from I0. I wish they would have reworded that, but it is separate and we're going to find that too. To start off this problem, we are going to look at this R equivalent right here. So that means we're going to have to add up all the resistors. These are the two formulas that we're going to use. The one on the left is for resistors in series, and the one on the right is for resistors in parallel. The first resistors we're going to look at are these far two right here. They are in series, so this is going to be 20. Next, we're going to look at the ones in parallel, and our 20 ohm resistor that we just found is in parallel with this 4 ohm resistor, which is also in parallel with this 5 ohm resistor. So plugging this into our formula, I'm going to surround this in parentheses. We're going to have 1 divided by 5 plus our 1 divided by 4 plus our 1 divided by 20, and then this is all being raised to the power of -1. And then if we do this, we're going to see that we have a 2 ohm resistor. Redrawing this circuit, it's going to look like this. However, instead of a 5 ohm resistor here, this is going to be our 2 ohm resistor. Now, since these are all in series, this 2 ohm resistor, this 2 ohm resistor, and this one, we're just going to add them together. That will give us a 6 ohm resistor. So this is our R equivalent. It is 6 ohms for this problem. Next, we are going to look for the current I0 through the 4 ohm resistor. To do this, we are going to use V I0 is equal to our current I0 times our resistance of I0. This will give us the exact current flowing through here since it's in parallel. And in parallel circuits, the current divides. Our 5 ohm resistor is in parallel, our 4 ohm resistor is in parallel, and our combined 15 and 5 ohm resistor is in parallel. So I rewrote this formula to be V I sub naught over 4 ohms is equal to I naught. This means that we have to find our V I naught. Well, we're kind of in luck because the 3 lines I just drew is because they're in parallel, and voltages in parallel is the same throughout. So our V subscript I naught is going to be the same voltage for all of these 3. That means if we look back at this that we drew a second ago, our 2 ohm resistor is going to be associated with a V subscript I naught that we can just use for the 4 ohm and our combined 20 ohm resistor. To find our V subscript I naught, we need to set this equal to the current flowing through here. And the current flowing through here is going to be our initial current. We start it here, we can just see it flows through like that. It's initial, and it's not being changed because it's going through a circuit in series. A circuit in series has the same current throughout. So we need to find this current and multiply it by the resistance that our Vi0 is feeling, which just happens to be 2 ohms, because now we need to look for our I right here. Once we find that, we will have our Vi0. So our I, our current for our system, is equal to the voltage of our system divided by the resistance of our system, and this is kind of a derivation from this formula right here. Plugging in these values, we're going to get that our current is equal to 120 divided by 6. That means our I is equal to 20 amps. This means that our V subscript I naught is equal to 40 volts. So we could plug 40 volts into our Vi naught here, and then we're going to have a 40 volts divided by 4 ohms. This is going to give us a resistance of 10. So our I naught is equal to 10. Unfortunately, we cannot use Vi naught, even though that our 3 parts right here are in parallel. And that is because our Vi naught is actually not in parallel. It's in series with this. Our 20 ohm resistor is a combination of this 15 ohm resistor and this 5 ohm resistor. And since they are in series, we have to know that our voltage is different. Voltage is only the same throughout if they are in parallel. So we have to use a formula that is in the notes provided, linked below, on section 3.3 and 3.4, voltage divider and current divider. And this formula looks like this, where instead of V1, we are going to have a V0. We know this Vs to be 40 volts. Normally the Vs would be our starting current, which would be this 120 volts. However, it's 40 volts because there's actually 40 volts going into this part of the circuit, because this part is equal to 40 volts. The system voltage is the part that's actually going into the resistor. Then we are going to have our resistor 1. In this instance, it is 5 ohms. Then we're going to have our resistor 1 plus our resistor 2. We know this to be 20 ohms. And then if we multiply 40 by 5, we're going to get 200, and then divide this by 20, we are going to get 10. So this means that our V0 is equal to 10 volts. And that is how you do this problem. If you found this useful, consider giving it a like. If you want to see more problems like this, there's a playlist linked in the description below. If you have any questions about this material, feel free to leave them in the comments and we will get back to them. And lastly, good luck on your studies.